Welcome to the Environmental Optics Lab. We call it Environmental Optics Laboratory because we try to apply optical methods using lasers substantially to study environmental problems, and especially related to the atmosphere. So problems related to pollution and to climate change mostly. And in particular, we care a lot about the particles that are in the atmosphere that are called aerosol, and they are affecting climate especially. So even right now, between the camera and myself, there are millions of these particles around. We just don't see them because they're very tiny, and so we have to apply kind of new ways to detect them. And so what we do, for example, here we have these two long tubes. What they are pipes where we can introduce this particle from the air. And what we do, we shine a laser, which is a very particular laser. It's a white light laser. It emits like a light that is white instead of being a specific color. And so it's similar a little bit to the light from the sun. And so we kind of simulate what the sunlight will do. And we bounce the light back and forth many times, and with that we can amplify the signal of these particles that are otherwise not very visible. On the other side here, if you want to take a look, we have other instrumentation that instead measures. What we do is very interesting. That's you shine a laser to something that is black, that is absorbing, and when they absorb, they emit a sound, and so we actually listen to their response to light, and that allows us to measure this even more difficult quantity, which is how much this particle absorbs solar radiation. So we are in the Quantum Optics Laboratory of Professor Su, and what he does here deals with single photons, and they might be future for computing, for cryptography, and single photon imaging. He adds them, subtracts them, can do medical diagnostics and almost everything what you can imagine. So we are in Laser Atomic Molecular Physics Laboratory. What we do here, we develop new lasers, and the primary application of their use is to detection of explosives. So here the laser development, and we move further. Here this is our detector. This is laser-based instrument which allows us to measure the temperature with the precision of 1 part in 100,000. If we achieve that, we can predict climate, moving of hurricanes and everything else in the world of this category. We also use it for medical diagnostics. People's breath contain typically just water and carbon dioxide, but they are ill. Their body produces traces of acetones and other compounds. Detecting them in person's breath can serve as a useful diagnosis. So what you see here is a plasma processing reactor, and these are used for making super semiconductors, processors in your computer, memories, GPSs, and all other micro devices. We try to improve the process to allow manufacturers to make smaller and smaller electronic parts. So this is our ultra-sensitive detector, which might be capable to determine whether you are infected with coronavirus.
This is the cloud chamber at Michigan Tech. It's a laboratory facility that we study the impacts of aerosols and cloud interactions on the environment. So it's a controlled environment where we control temperature, pressure, and the humidity, and we actually form clouds inside.